Hello students, today we'll discuss the assignment number 3 on set theory. Okay, so your first question is here, and this question is, sir, a minus b is equal to a and b minus a is equal to b, so what can we conclude from here? So first of all, let's say if you have two sets p and q, so what is the meaning of p minus q? So meaning of p minus q is collection of all elements which is in p, but your element is not the member of q set. Okay, so p minus q means what? Collection of all element which is in p but not in q. Okay, that's p minus q. So if you have a minus b is equal to a minus b is equal to a. Okay, it means what? It means what? A minus b is what? A minus b is collection of all elements which is in a but not in b, and a is what? The complete set A. Yes, so if a minus b is equal to a, so meaning of this thing is what? If you choose any element in your set A, if you choose any element in your set A that is not in B, okay, so you can say if x belongs to A, if x is any element of A, then x does not belong to B. Okay, because a minus b is equal to a, so if you choose x belong to a, if you choose any element in a, then that element is not in your set B. Okay, that's the thing. And similarly, I have one more information that b minus a is equal to b set. B minus a is equal to b set means what? If you choose any element x1 which is in B, if you choose any element which is in B set, then that is not in A set. Yes, then that element x1 does not belong to your set A. Okay, so A minus B is equal to A implies if any element of A, if you choose any element in your set A, then that element not in your set B. And B minus A is equal to B implies if you choose any element in your set B, then that element does not belong to the set A. It means what? It means A and B do not have any common element. Okay, A and B do not have any common element. Any common element? Yes, A and B do not have any common element. So meaning of this thing is what? Meaning of this thing is, sir, A intersection B is equal to what? That's an empty set. Okay, so from here we can conclude that A intersection B is equal to empty set. So whenever intersection of two set is empty, then you can say A and B are disjoint. A and B are disjoint sets. Okay, disjoint sets. So this is your answer. Okay, now next question is here we have, this is, if A intersection B is equal to A union B, then what can we conclude? Okay, sir, now we know one thing. First of all, if A is subset of B and B is subset of C, okay, we know this thing. If A is subset of B and B is subset of C, then A is subset of C set. We know this thing. Yes, if A is subset of B, B is subset of C, then A must be the subset of your set C. Okay, so now, sir, we know one thing, that A intersection B is what? A intersection B is subset of A, because A intersection B is collection of all the common elements of A and B. So it means every element of here belongs to the set A. And we know, and A is what? A is subset of, A is what? A is subset of A union B. Yes, because if you choose any element from A, that must be in your A union B. Okay, because of the definition. So from here we know that A intersection B is what? A intersection B is A union B. So we can say A intersection B is subset of A, and A is subset of A union B, and this is equal to A intersection B. So A intersection B. Okay, so we can say A intersection B is subset of A. Okay, and A is subset of A intersection B. It means what? It means A is equal to A intersection B. Okay, now similarly, sir, A intersection B is, similarly you can say A intersection B is subset of B, and B is subset of A union B. So now A intersection B is subset of B as it is, and B is subset of A union B, and A intersection B both are same. So A intersection B. So from here what can we conclude? So we can conclude A intersection B subset of B, and B is subset of A intersection B. So B is equal to A intersection B. Okay. So from these two, A is A intersection B, B is A intersection B. So we can say A is equal to what? A is equal to B set. Okay, both these sets are equal, we can say. Got it? Now let's do the next one. Next is show that A intersection B is A intersection C need not imply B equals to C. Okay, then let's take A is equal to 1, 2. B is equal to 1, 2, 3. C is equal to 1, 2, 5. Clearly, if you check A intersection B, so A intersection B is equal to what? A intersection B is 1, 2. Okay. A intersection C is what? A intersection C. A intersection C is 1, 2. So both are equal. A intersection B equals to A intersection C. Yes, both are equal. But B is not equal to C. Yes, B is not equal to C. B is not equal to C. Why? In C we have 5, but in B we do not have 5 element, means element 5. Okay, so both are not equal. So that's the example for your question. Next is so consider the following sets. A is set of all rectangles in a plane. Okay, B is set of all squares in the same plane. Okay, C is set of all parallelograms in the same plane. Okay, now find A minus B. A minus B is what? A minus B set. So A minus B, which is in A but not in B. So collection of all rectangles which are not square. Yes, all rectangles, set of all rectangles. Okay, A minus B means set of all rectangles which are not square. Which are not squares. Okay, set of all rectangles which are not square. This is A minus B set. Okay, next one is what? C minus A. C minus A is, C minus A means set of all parallelogram which is not a rectangle. Okay, set of all parallelograms which are not rectangles. Okay, or which are not squares, you can say. Again, which are not rectangles or square, but we know that squares are rectangle. Yes, every square is a rectangle, you can say. Okay, but converse is not true. So here you can say C minus A means collection of all parallelograms which are not rectangles. Got it? That is C minus A, collection of all parallelogram which are not rectangles. Got it? A intersection C. Next one is A intersection C. A intersection C. So if you observe, A is set of all rectangles, C is set of all parallelograms, and we know every rectangle is a parallelogram. Okay, so it means C intersection A is what? C intersection A is A. Yes, because A is what? A is subset of C. We know every rectangle is a parallelogram, so A is subset of C. Okay, A is subset of C, so A intersection C is what? A intersection C is A set. Why? Because A is subset of C. Okay, so A intersection C is set of all rectangles. Set of all rectangles. Got it? Next one is what? Next one is B intersection C. B intersection C. B intersection C. Again, B is what? Set of all squares, and C is set of all parallelogram. So every square is a parallelogram. So B is subset of C. So B is subset of C. So that's why B intersection C is what? That is B. So you can say set of all squares. This is what? Set of all squares. Okay. Next one. Next is B union C. B union C. B union C. B union C is what? B is subset of C. So B union C is C, set of all parallelograms. Set of all parallelograms. Okay. Next thing is what? That is A intersection B intersection C. A intersection B intersection C. A intersection B intersection C. So A intersection B intersection C is what? We know set of all rectangles. A is this, B is set of all squares, C is set of all parallelogram. So we know every square is a rectangle. Yes, every rectangle is not a square, but every square is a rectangle. So B is subset of A. We know B is subset of A and A is subset of C. So A intersection B intersection C is what? That's B, set of all squares. Yes, set of all squares. So this is your answer. Yes, A intersection B intersection C. So that's your question number 4. Now let's do the next one. Assume that power set of A is equal to power set of B, then show that A is equal to B. Power set is what? Power set is collection of all the subsets. Okay. So sir, if you choose any element from A, let X belongs to any element of A. X is any element of A. If X belongs to A, from here you can say subset of this X belongs to power set of A. And power set of A and B are same. So we can say this subset X belongs to power set of B. Okay. If subset X belongs to power set of B, it means what? X belongs to B. So X is any arbitrary element of A and that X belongs to B also. So you can say A is what? A is subset of B. Okay. Similarly, let some Y which belongs to B. Okay. Let Y belongs to B. So it means what? It means subset Y belongs to power set of B. Okay. And power set of A and B both are same. So you can say subset Y belongs to power set of A. So it means what? It means Y belongs to set A. So from here you can say B is what? B is subset of A. So from these two, we can say A is subset of B and B is subset of A. So let's say this is 1, this is 2. So from 1 and 2, from 1 and 2, we can say A is subset of B, B is subset of A. So A is equal to B. Okay, this is the proof. Got it? Now let's do the next one. Sixth question. And solution is here. Sir, A is equal to minus 3 comma 2. semi-closed, semi-open interval. Similarly, B, you have to find A minus B, B minus A, union B and A intersection B. So let's draw your number line. Okay, if you draw your number line, let's say this is the number line. Okay, you have A minus 3 to 2. Let's say minus 3 is somewhere here and 2 is somewhere here. Okay, so minus 3 open to 2 close. Got it? B is minus 1 to 5. B is minus 1 to 5. Minus 1 is, let's say, somewhere here and 5 is somewhere here. Minus 1 to 5. Minus 1 open, 5 close. Minus 1 open and 5 close. Okay. First, A minus B. You have to find A minus B. Okay, so A set is minus 3 to 2. So this is your A set and this is your B set. Okay, B set. A minus B is what? Or you can write in terms of interval here. Sorry, this is B set. So you can write A minus B. A minus B is equal to what? Which is in A but not in B. So that portion is what? That portion is minus 3 to 1. Yes, this portion. Yes or no? If you observe this portion, which one? This portion. Till here. Yes, means till here. So you can say this is in A but not in B. Yes, if you choose any other element, then that is also in B. So A minus B means what? Minus 3 to minus 1 and minus 1 close, because minus 1 is in A but not in B. So you can say minus 3 open to minus 1 close. B minus A. B minus A, that is what? B minus A is, so you have A till here. Yes, B minus A is 2 open. Yes, 2 open to 5 close. 2 open to 5 close. That's B minus A. A union B. A union B. A union B is what? A union B. That's minus 3 to 5. Minus 3 to 5. 5 close, minus 3 open. Next is A intersection B. A intersection B. Collection of common elements. Common elements are minus 1 open to 2 close. Minus 1 open to 2 close. Okay. Minus 1 open to 2 close. These are the common elements. Got it? So this is your question number 6. Now next one is it true that for any set A and B, power set of A union power set of B is equal to power set of A union B? No, this is not true. No, this is not true. How? If you take A set as 1, 2, B set as 2, 3. Okay. Now, A union B is what? A union B. A union B is equal to 1, 2, 3. Yes, 1, 2, 3. Okay. Now write the power set of A. Power set of A. Power set of A is what? Power set of A is 5 empty, 1, 2 and 1, 2. Okay. Write the power set of B. Power set of B is what? Empty, 2, 3 and 2, 3. Power set of A union B is what? Power set of A union B. Power set of A union B, that is empty, 1, 2, 3, 1, 2, 1, 3, 2, 3 or 1, 2, 3. Okay. these 8 elements. And if you calculate PA union PB, PA union PB, power set of A union power set of B, that is empty 1, 2, 3, empty 1, 2, 3, okay, 1, 2, 3, 1, 2 and 2, 3, 1, 2 and 2, 3, yes, are they equal? Clearly P of A union P of B is not equal to power set of A union B. Okay, so the given statement is not true. Why they are not equal? Because here we have 1, 2, 3, here we do not have. Okay, so both are not equal. So now the next question is, so here, so let A, B and X be 3 sets such that we have some condition A intersection X, B intersection is equal to empty, and A union X, B union X both are equal. You have to show A is equal to B. Okay, so if you write A set, so A can be written as what? A can be written as, sir, A intersection with A union X. Very simple, very simple. A can be written as A intersection A union X. So this is what, this is the A set. Okay, so now A intersection, you can write A union X is what? B union X, B union X. Yes, now you know distributive law, that is A intersection B union A intersection X, and A intersection X is what? Empty. So you can say this is A intersection B union empty. So this is equal to A intersection B. So A set is equal to A intersection B. Similarly, if you find B, okay, so you can say B is equal to what? You can say B is equal to B set intersection with B union X. So you can say B intersection B union X is A union X. This is given to us. Yes. So from here you can use distributive law. B intersection A union B intersection X. B intersection A union B intersection X. And B intersection X is empty. So you can say this is B intersection A union empty, which is B intersection A. And we know B intersection A is equal to A intersection B. Okay, so from here and here, from let's say this is 1 and let's say this is 2, so from A and 1 and 2, from 1 and 2, what can we conclude? A is A intersection B, B is A intersection B, so A is equal to what? A is equal to B. Okay, and this is your proof. Okay, next question. Question number 9. Solution. If A minus B is empty, B minus A is empty, then what can we conclude? Okay. A minus B is empty means what? Every element of A is in B. Yes or no? A minus, here your solution is what? Solution is, sir, A minus B is equal to empty. A minus B is equal to empty set. A minus B is equal to empty. A minus B empty means every element of A is in B. That's why when you take A minus B, you will get empty set. So every element of A is in B. Okay. From here you can say every element of set A is in set B. A minus B is equal to empty means every element of set A is in set B. So it means what? A must be the subset of B. If every element of set A is in set B, so you can say A is subset of B. Okay, and you have one more condition, and B minus A is empty. B minus A is equal to empty. So you can say what? You can say every element of set B is in set A. So it means what? It means B is subset of A. If A is subset of B, B is subset of A, so from here you can say A is equal to what? A is equal to B. So that's the conclusion from the given information. Now next question. Solution is what? You have to verify your associative property or prove your associative properties for the union of given sets. Okay, for the union of given set. So associativity is what? Associativity is that A union B union with C is equal to A union with B union C. Okay, that is what? That is the associative property for the union of sets A, B and C. First of all, if you take union with union of A and B, and then the resultant union of this resultant set with C, this is equal to A union, first of all take B union C. Okay, so A union B, then union with C is equal to A union B union C. Okay, so for the left hand side, that is A union B. First of all calculate A union B. A union B is what? A union B is A B C D E, A B C D E F G H, F G H. That is A union B. Now take union with C. So C is what? C is G H I J K, G H I J and K. Okay, so if you simplify this thing, you will get what? A B C D E F G H I J and K, I J and K. This is your left hand side. Now what about right hand side? Right hand side is, so first of all take A as it is, A B C D, that is A B C D and E, and take the union with B union C, and B union C is what? D E F G H I J K, D E F G H I J K. Okay, if you calculate, so you will get what? Union as A B C D E, A B C D E F G H I J K, K. Okay, so observe these two sets, these two things, they are equal. A B C D F G H I J K, A B C D F G H I J K, both are equal. Okay, so you can say this is the proof of the associative property for the given sets. Okay, next thing, next question is, sir, this is your single correct MCQs. Okay, so here you have your first question in MCQs, and solution is, for any two sets A and B, then A minus B union A intersection B is what? Okay, A minus B. Okay, let's take the Venn diagram here. Okay, so let's say this is your universal set, this is your universal set, got it, no problem. Now A and B, this is let's say set A, this is let's say set B, set A, set B. So A minus B is what? Sir, A minus B. First of all, for two sets A and B, find A minus B union A intersection B. So A minus B is what? A minus B is this one, this portion, which is in A but not in B. Yes, that's A minus B. Okay, good. Next is A intersection B. Take A intersection B also. A intersection B. A intersection B is this one. This is what? This is A intersection B. Yes, this is A intersection B. Now, take the union of both. If you take union of both, you will get what? The union of both is this portion. This portion, this green portion, yes. This green portion. and this is what, this is your A set. Yes, so answer is set A. So answer is set A. Answer is set A. So C is the correct answer. Okay. Now next question. A is this, B is this, A intersection B. So A intersection B is what? A intersection B is the collection of common elements. A intersection B, that is common element 2. No. 4. Yes, 4 is common. Next 7. No. 11 is common, 14 is common. Yes. So 4, 11 and 14. These three elements are common. So this is your intersection. So 4, 11 and 14. So answer is A here. Okay. Next is. Okay then. Now. Sir, we have some diagram here. We have diagram here that represent, bigger circle represent employed people, smaller circle represent backward people, and triangle represent the educated people. So you have to find out how many educated people are employed. Okay, so bigger circle. Okay, you have to find the common area of your bigger circle and triangle. So bigger circle and triangle, this is triangle and this is your bigger circle. So common portion is this one. Yes, so common portion is this one. So this portion says we have, in this portion we have educated people and employed. Yes, so we have to find what, how many educated people are employed. So 6, this number is what, 6 plus 3, that 6 plus 3 is 9. So A is the answer. Yes, 6 plus 3, total 9 we have. Okay, so final answer is A. Next is here. So which of the following diagram indicates the best relationship between the travelers, train and bus? Yes, so train and buses are disjoint set. You cannot say some bus is a train or train is a bus. Okay, so it means you have two disjoint sets. Very good, first thing. And what about travelers? Travelers can choose even train or bus. So the third set is intersected in the third set intersect other two circles. So this is not the case. Yes, two circles are disjoint, but third one is completely in one set. Yes, in one circle. So this is not the case. Next thing is this one. No, all three are disjoint. So this is not the case. What about this one? No, this is not the case. And here if you observe, this is what, this is first circle, this is, let's say, train. Okay, and this is your second circle, this is what, let's say this is bus. Okay, train and buses are disjoint, and travelers is what, traveler intersect with both the things. So this is what, this is your travelers. Okay, travelers. Got it? So this is the correct one. C is the correct answer. Now next question is, you have some universal set, A set, B, C and D set. You have to find A intersection B. Okay, so A intersection B is what? A intersection with B. So A intersection B is 3, 4. Yeah, 3 and 4. Yeah, 3 and 4. Common elements, yes. B union D. A intersection B is common element of A and B, that is 3 and 4. Next is B union D. So collection of all the elements of B or D. So that is 1, 3, 4, 5. 1, 3, 4, 5. That's B, and elements of D are 4. We already have 9, 11 and 12. 11 and 12. Yes, 1, 3, 4, 5 and 4 already have 9, 11 and 12. This is your B union D. So now you have to find the intersection of both. So A intersection B, this is some set. You have to take the intersection of this thing with B union D. So B union D. So common elements of these two sets, and these are 3, 4. So 3, 4. So correct answer is B. Okay, this is your correct one. Got it? So next question is, Okay, that's from the revision part. Okay, and let's do the question here. If the seventh term of an AP is 1 by 9, ninth term is 1 by 7, find the 63rd term. So let's say for your AP, your first term is A and common difference is D. Okay, first term is A, common difference is D. So seventh term means A plus 6D. You already know. Nth term, formula for nth term is what? Formula for nth term is A plus n minus 1 into D. For the seventh term, you have A plus 7 minus 1, 6D. Okay, so this is seventh term, A7. Seventh term is 1 by 9. So A plus 6D is 1 by 9. Okay, next. And the ninth term is 1 by 7. Ninth term. That is A plus 8D. This is equal to what? 1 by 7. So now when you subtract it, you will get what? Cancel A minus A 0. That's 6D minus 8D. That's minus 2D is equal to 1 by 9 minus 1 by 7. So when you take LCM, so this is 63. That is 7 minus 9 minus 2 by 63. Okay, so from here you can calculate D. D is 1 by 63. Okay, you can cancel minus 2 from both the sides, so you'll get D. So now you have D. So put value of D in equation 1, let's say. So if you put here, you'll get what? A plus 60, that is 6 by 63 is equal to 1 by 9. 1 by 9. Okay, which implies A is equal to 1 by 9 minus 6 by 63. So when you simplify it, LCM is 63. So 7 minus 6, which implies A is equal to 1 by 63. Okay, 1 by 63. Got it? Now you have to find what? 63rd term. So 63rd term is what? A 63 is equal to A plus 62D. Okay, so this is A is 1 by 63 plus 62D is what? 62D is 62 by 63. That's 63 by 63. That is equal to 1. So this is the answer. Okay, so this is the final answer. Now let's do the next one. The sum of fifth and ninth term of an AP. Again, first term is, let's say, A and common difference is D. Okay, so you have fifth and ninth term. So fifth term is A plus 4D and ninth term is A plus 8D. The sum of these two terms is 30. And if its 25th term is 3 times, 25th term, that is A plus 24D is equal to, if 25th term is 3 times its 8th term, 8th is A plus 7D. Okay, then find AP. Okay, then so from here you can say A plus A, 2A plus 4D plus 8D, 12D is equal to 30. Okay, and from here you can conclude A plus 24D is equal to 3A plus 21D. 3A plus 21D. So if you simplify, you will get what? You can take A on that side, so you will get 2A is equal to 21D on the left hand side, so that is 4D. Okay, 2A is equal to 4D. So put 2A is equal to 4D in the equation number 1. Okay, fifth term is A plus 4D, ninth term is A plus 8D, that's 30. A plus 24D is 3 times the 8th term, A plus 7D. So that is A plus 24D is equal to 3A plus 21D. So you can say 2A is equal to 24 minus 21, that's 3D, sorry, that's 3D. Okay, that's what? That's the 3D. 2A is equal to 3D. Okay, and 2A plus 12D is equal to 30. So put this thing in equation number 1. So 2a is 3d, so you can say 3d plus 12d is equal to 30. So if you simplify, you can say 15d is equal to 30. So d is equal to 2. So if d is equal to 2, now 2a is equal to what? 2a is equal to 3d, 3 into 2. So you can say a is equal to what? 3. A is equal to 3. Now we know a and d, so you have to find the AP. So AP is 3, 3 plus 2, 5, 7, 9, 11 and so on. So that's your required AP. Okay. Now let's do the next one. Find whether 0 is a term of the AP or not. Okay. Let's say if 0 is the term, then that term is nth term. So let's say nth term is equal to 0. So nth term is what? Nth term is a plus n minus 1 into d. That thing is, let's say, 0. Okay. A is what? If here in this AP, if you observe, a is 40, first term, and common difference is 37 minus 40, that is minus 3. Okay. So this is 40 plus n minus 1 into minus 3 is equal to 0. Okay, so from here you can say 3 times, or let's do like this, 40 plus and 40 minus 3 into n is minus 3, and minus minus plus 3 is equal to 0. So from here you can say 3n is equal to 43. So you can say n is equal to what? N is equal to 43 by 3. And this is not an integral value. 43 by 3 is what? That is 3 ones are 3, 1, 1, 3, 4.3333. Yes. So 14.333. N is this. But we know n is what? N must be a natural number. So it means there does not exist any n for which an is 0. So it means 0 is not the. So 0 is not the term of given AP. Okay, that's the answer. Now let's do the next one. Next is, so solution is here. Find the middle term of given AP. Okay, so if you observe the given AP, A is equal to 213, A is equal to 213. Okay, D is what? D is 205 minus 213, that's minus 8. Last term is what? 37. Nth term is 37. So find first of all n. So you can say A, nth term is 37. So A plus n minus 1 into D is equal to 37. Yes. So when you simplify it, you will get what? N minus 1 into minus 8. N minus 1 into minus 8 is equal to 37 minus 213, which is equal to what? 6. Okay, 6 and minus 70 means 176 with minus sign. So now if you divide both sides with minus 8, so you'll get n minus 1 is equal to minus 176 divided by minus 8. So you can cancel minus with minus, and this thing is 22. Okay, so n is equal to what? N is equal to 23. N minus 1 is 22, so n is equal to 23. So total number of terms are 23 here. So what is the middle term? Middle term is middle term. Okay, middle term is what? That is 23 plus 1 by 2th term, and which is 24 by 2, that's 12th term. Okay, 12th term. Okay, so 12th term is what? We have to find the middle term. So 12th term is A plus 11D. A is what? 213. 213 plus 11 into D. D is minus 8. Okay, and this thing is what? 213 minus 88. And this thing is what? This thing is 5. Okay, 125. That is 125 is the answer. So that's the answer. Now next is what? Next question is, and the last question of this assignment, this is if the fifth term of an AP is this, 25th term is this, find the AP. So let's say again for the given AP, first term is A and common difference is D. Okay, so we are given with fifth term of the AP is 31. Fifth term means A plus 4D, that is equal to 31. Okay, second information, 25th term. 25th term is A plus 24D is equal to 140 more than the fifth term. So fifth term is A plus 4D and 140 more than the fifth term. So this is the situation. So you can cancel A with A. Okay, you can take 4D here. So that will be 20D is equal to 140. So if 20D is equal to 140, so D is equal to 7. Okay, put D is equal to 7 here. If D is equal to 7, so A plus 28 is equal to 31. So from here you can say A is equal to 3. Okay, now you have first term and common difference. You have to find what? You have to find the given AP. So AP is what? AP is 3. Then 3 plus 7, that is 10. Next is 17. Next is 24 and so on. Okay, common difference is what? 7, 7, 7. First term is 3. So this is your given AP. Okay, so this is your assignment number 3 on set theory. In next video we will discuss the assignment number 4. Till then, bye bye. Thank you everyone.